How can we address the 2.5 million tonnes of plastic reaching end of life every year in Australia? With its vast road network, Australia has an opportunity to repurpose waste plastics into a potential resource for our transport industry. Can we use circular economy principles to help tackle the problem? The National Asset Centre of Excellence, or NACO, and the Western Australian Road Research and Innovation Program, or WARRIP, set out to get an understanding of the opportunities and implications of using recycled plastic in road construction.
So this project has been a pretty far-reaching project. We've set out to cover a number of topics, including assessing potential end uses for waste plastic, including standalone applications and as modifiers in pavement. We've also looked to understand the potential for using problem waste plastics in our road infrastructure. Additionally, we look to understand the health, safety and environmental impacts of putting waste plastics into our infrastructure. And we also reviewed the performance of recycled plastic modified asphalt and compared that to conventional materials.
Even if all the bitumen used in Australia included 6% of plastic, this would only equate to less than 1% of the waste plastic generated annually. So finding other uses for recycled plastic is essential.
We carried out a comprehensive literature review and analysed standards and specifications. Through this, we identified a number of possibilities. We learned there are opportunities for recycled plastics in a range of applications. They can be used in geosynthetics and geotextile, for filtration or to provide underlying support to pavements. They can be used in temporary traffic management devices such as traffic cones and bollards. And they can be used in noise walls, pipes, wheel stops, outdoor furniture, fencing and boardwalks. We focused on identifying products with recycled plastics that would provide engineering equality or improvement or are low-risk applications. For the products with recycled content already available, such as traffic cones, we have found that the awareness across industry is low and the current usage volumes are not captured.
For waste plastics used in bitumen and asphalt in road construction, the project explored its health, safety and environmental impacts.
In the first instance, we assessed the fumes and emissions recycled plastics create when they are added in a laboratory environment. We used two common types of post-consumer waste plastics. Firstly, a soft plastic, namely low-density polyethylene, and a commingled high-density polyethylene and polypropylene. We benchmarked these against business-as-usual materials. What we learned is that the fumes emitted from the plastics modified samples were relatively comparable with those of conventional bituminous materials. And in fact, they were below the Safe Work Australia exposure limits or limits recommended by the Australian Institute of Occupational Hygienists.
Next, the team investigated the leachability risk of recycled plastic modified pavements.
So we used Australian methods for testing soil leachability and we explored a novel protocol as well. However, to get a thorough understanding, we recommend continuing assessing these leachability impacts.
The final health, safety and environment investigation looked at the potential for microplastics to be released into the environment.
This study involved the development of a specialised assessment methodology. To simulate friction under load from heavy vehicles, we aged and then abraded slabs of plastic modified asphalt as well as conventional asphalt. We collected the abraded material and then quantified its composition using thermogravimetric analysis. The results demonstrated that microplastics generated from recycled plastic modified asphalt were comparable to that of conventional polymer modified asphalt, which is routinely used in both Queensland and Western Australia.
Polymer modified asphalt mixes are used in Queensland and Western Australia to ensure the performance of heavily trafficked networks and reduce the risk of premature failure. So the project also reviewed different asphalt performance data.
We identified that recycled plastic modified asphalt may perform better than unmodified asphalt in certain applications. However, the test results suggested that recycled plastic modified asphalt is not comparable to conventional polymer modified asphalt.
This project has highlighted ways to utilise recycled plastics on the network, from geosynthetics to traffic management. It has quantified initial health, safety and environmental impacts of reusing plastics. And it has produced a better understanding of the performance of recycled plastics in asphalt. You can read the published reports and keep up to date with further research on the NACO and WARRP websites.